Alright folks, we're going to be looking at our first section over here, which is dividing a polynomial by a binomial. We're going to be doing this in two possible ways. So the first method we're going to do it is using long division. Now the long division we're going to do is going to be pretty similar to the long division you've been doing since you were a kid. So first things first, we're going to set up our polynomial in a long division form. So we are dividing 3x squared minus 4x plus 5 by x minus 2. So the first thing we need to ask ourselves is, x multiplied by some number is going to give us 3x squared. X multiplied by what is going to give us 3x squared? And the answer is x multiplied by 3x is going to give us 3x squared. We then take that 3x and we also multiply it by the negative 2. So 3x times a negative 2 is going to give me a negative 6x. If you think of it as a monomial multiplied by a binomial, 3x times an x minus 2 gives you 3x squared minus 4x. And just like you did with long division, you now have to subtract the top and the bottom. So when you subtract over here, what's going to happen is the signs are going to change. This is going to become a positive sign. Then I collect like terms. So 3x squared and a negative 3x squared is going to be 0. Negative 4x and a positive 6x is now going to give you a positive 2x. Similar to long division, once you've done that, you got to bring down the next term. In this case, the next term is 5. So I'm going to bring down the plus 5, making it a binomial again. And then I ask myself the same question. X times something is going to give me 2x. X times a positive 2. So plus a 2. Because they're working with polynomials, the terms need to be separated by either a plus or a minus sign. So x times a 2 is going to give me 2x. And then 2 times a negative 2 is going to give me negative 4. Again, I need to subtract both of those. So when I subtract them, the signs are going to be changing. So when I subtract, this is going to become a positive sign. And then I simply collect like terms. So let's collect like terms. 2x and a negative 2x is going to become 0. 5 plus a 4 is going to become a positive 9. This is as far as we can go. You've now got x minus 2 when it divides into 3x squared minus 4x plus 5. The result is 3x plus 2 with a remainder of 9. We can write this answer using a division statement. A division statement says P equals D times Q plus R, which means polynomial equals divisor times the quotient plus the remainder. So let's identify what each part is. Okay, this is the polynomial. This is the divisor. This is the quotient. And of course, this is the remainder. So when I write my division statement to finally present the answer here, I'm going to get 3x squared minus 4x plus a 5 is equal to x minus 2 times 3x plus 2 and then plus the 9, which is a remainder. I can also write it in another form. I can also say that 3x squared minus a 4x plus a 5 divided by the x minus 2 gives me 3x plus 2 and then plus a 9 over x minus 2. Right, just like you wrote fractions. So the inside part divided by a number is going to give you the quotient, and then the remainder was always written as a fraction of the remainder and the divisor. So 9 over x minus 2. And that is going to be the first part of our problem. At this point in time, you can go ahead and try the next example to the right side over here and check your answer to see if you get it correct. I'm going to pause the video here for a second, and I'm going to let you go ahead and try example number 2. So you should pause the video right now, try it, and then come back and check and see the answer, because I'm just going to go ahead and solve it and then have the final answer presented here for you to confirm your work with. So magically, you're only going to see the final answer. Take a look right now. We've got that example done. We'll just go ahead and rewrite or write the answer in proper form in a division statement. So again, I can say this time the remainder of a 0, so I can say 2x cubed minus x squared minus a 2x plus a 1 equals x plus 1 times 2x squared minus 3x plus 1. Okay, so that's what it works out, but there's no remainder, so there's nothing going to be added to that over there. Alright, so our steps that we used are now identified over here. You can recap these steps to help you do the next problem, so I'll let you go ahead and read through that when you get a chance, those steps. Our next example we're going to try is going to be dividing another polynomial by a binomial, but it's going to be a little bit different from what we've done so far. So let's take a look at our next example, which is example number 3. We want to divide that polynomial by x minus 1. So one of the things you'll notice right away is not everything is in order. We got an x cubed term followed by a 5, followed by a negative 2, followed by 3x squared. So before we can go ahead and get started, we have to rearrange the polynomial in descending order. So let me go ahead and rewrite that. When I rewrite that, I'm going to get 2x cubed plus 3x squared minus 2x plus 5. I also have to make sure that all the terms are there in descending order. If something was missing, I would add 0 of that amount. And I'm going to be dividing it by x minus 1 this time. So that's the pretty much tricky part of this problem. Once you set it up this way, it's pretty easy to solve. So once again, we'll go ahead and do it. So x goes into 2x cubed, 2x squared times. So 2x cubed. 2x squared times a negative 1 is going to give you a negative 2x squared. I'll subtract. Okay, when I subtract, the signs change. So that means I'm now going to have 2x cubed minus 2x cubed goes away. 3x squared plus a 2x squared is going to give me 5x squared. Bring the negative 2x down. Again, x times a positive 5x is going to give me 5x squared. And then a positive 5x times a negative 1 is going to give me a negative 5x. Again, I need to subtract. Change the sign. Collect like terms, and I get negative 2x, positive 5x is going to give me a positive 3x. Bring the positive 5 down, so plus 5. Repeat the process. X times a positive 3 is going to give me a positive 3x, and then a positive 3 times a negative 1 is going to give me a negative 3. Change the signs. Collect like terms. It's kind of like instructions on your shampoo. Rinse, repeat, rinse, repeat. We're going to keep doing the same stuff. So 5 plus a positive 3 is going to give you 8. And it's as far as we can go. Nothing more left. Only part left is to write that in a division statement, and this time your division statement is going to look something like this. I can say 2x cubed plus 3x squared minus 2x plus a 5 equals x minus 1 times 2x squared plus a 5x plus a 3, and then plus a remainder of 8. This is your division statement. Alright, so just a quick review. Division statement, again, simply is a way to write the answer to the polynomial division. So we're just going to go ahead and quickly check the division statement that we wrote down up here for example number 3. So I'm going to take the division statement, I'm going to go ahead and open it back up to try and figure out if it actually works. Left hand side equals right hand side. So what I had written down was this: 2x cubed plus 3x squared minus 2x plus 5 equals x minus 1 times 2x squared plus 5x plus 3, and then plus the 8. So what this is saying here is a polynomial, when it's divided by a binomial, the division statement relates the original polynomial and the divisor. We just talked about that earlier. The division statement goes as follows. P of x is x minus a times q of x plus r. It can also be simplified to the form p equals dq plus r. This is the polynomial, the divisor, the quotient, and the remainder. If you want to verify to see if it actually works, what we're going to do is just go ahead and open that up. I'm just going to go ahead and use your FOIL technique to multiply everything with everything, and then check to see if it works out. So when I do that, I'm going to get 2x cubed plus 5x squared plus 3x minus 2x squared minus 5x minus 3, and then the plus 8 that we had on the side. Go ahead and collect like terms. What I'm going to get is 2x cubed plus 3x squared minus a 2x plus a 5, and again left hand side equals the right hand side. So basically the division statement is just another way of rewriting the division that we are doing, or the polynomial that we have divided by the divisor. Alright, so now that we've done some of the easier examples, we can try one that's a little bit tricky. So this time you want to divide this expression by x minus 3. So one of the first things you will notice is that we've got an x4 term, we've got an x squared term, we've got an x term, and a negative 3, but we've got no x cubed term, right? So our x cubed term is missing. So what we're going to do is, whenever x cubed term is missing, or any term is missing, we're simply going to insert it into our equation as 0x cubed. So what that's going to do, it's going to rearrange my polynomial into this form. Negative 4x4 plus 0x cubed plus a 2x squared minus an x minus a 3. Right, and now I'm simply going to be dividing this by x minus 3. So that's my goal. I'm just going to move this down a bit here, so that way you got a bit of space to work with. So let me do that. So once we set it up, the rest of the steps are pretty straightforward from what we've been doing. We'll just go ahead and quickly finish this up. I will let you go ahead and give this a try. Do the same steps you've been doing, and then write the answer as a division statement. I'm going to take a bit of a pause here. You can pause the video, try it yourself, and then compare the answer that I'm going to show you in just a moment here. So if you go ahead and give this a try, we're going to get x times a negative 4x cubed will give us a negative 4x4, and then a negative 4x cubed times a negative 3 is going to give us a positive 12x cubed. Again, I need to go ahead and subtract, so when I subtract, it's going to change the signs over here, and then I collect like terms with the new signs. Right, so when I'm collecting like terms, I'm collecting them with the new signs now. So negative 4x4, positive 4x4 crosses off. 0x cubed minus 12x cubed is going to give me a minus 12x cubed. Bring down the next term, which is a positive 2x squared. X times a negative 12x squared is going to give me a negative 12x cubed. Negative 12x squared times a negative 3 is going to give me a positive 36x squared. Again, let's go ahead and subtract. That means going to change our signs over here. Collect like terms with the new signs. Negative positive crosses off. Positive 2x squared, negative 36x squared. We get negative 34x squared. Bring the next term down. Negative x. Again, repeat. Negative 34x times an x will give me negative 34x squared. Negative 34 times a negative 3 is going to give me a positive 102x. Again, subtract, change the signs. I'm going to get, those cross off, negative 103x. And the last part, bring the negative 3 down. So minus 103 will give you negative 103x and a positive 309. the last subtraction we're gonna do here. Change the signs again, and wish we had more room. Need more room here. You'll be left with a -3 and a -309, which is a -312. So when we write division statement for that, our division statement's gonna look like this. It's gonna be -4x4 plus 2x squared minus x minus 3 equals x minus 3 times -4x cubed minus the 12x squared minus the 34x minus 103, and then minus 312. So that's going to be our final answer there. So that will take care of working with long division. The other method that we can use to divide a polynomial by a binomial is synthetic division. So here's what synthetic division is going to look like. Synthetic division is a different method that can be used to divide a polynomial by a binomial. It has to be of the form x minus a. In this method, the variables are removed and only the coefficients are recorded. So we're not working with all the letters, we're only working with the coefficients. So I'll show you an example of what we're going to be doing. So we want to divide 2x cubed plus 4x squared minus 5x minus 6 by x plus 1. So because we're dividing by x plus 1, first we got to put it in form of x minus a. Now only expressions with no leading coefficient will work here. So if you had something like 2x minus 1 that you were dividing with, it won't work with synthetic division. Okay, so we can't do expressions like that. We just gotta have this x term with no leading coefficient in front. Alright, so let's erase that. Let's go ahead and work with this example. I'm dividing by x plus 1, so I'm going to first compare x plus 1 to x minus a. So this is the same as x minus a negative 1. That's x plus 1. Now it's in the form of x minus a, and the a value happens to be negative 1. That's the a value that I need before I can go ahead and do the synthetic division. Once I've got that a value, this is how I set it up. I simply write down negative 1 on the outside over here, and I write down all the leading coefficients of each of those terms given that they are already in descending order. So the leading coefficient was 2, a positive 4, a negative 5, a negative 6. I got to make sure if I'm missing any of the terms in there, I fill those in first before I go ahead and do this step. Now once I've done that, it becomes really easy. Here's a process that I'm going to use. Okay, let's do this. So first things first, I start off with bringing the 2 down. That's my first step. Bring the first leading coefficient down. Then you want to multiply the negative 1 and the 2. The negative 1 times the 2 is going to give you negative 2. You're going to put that over here, the negative 2. And then what you're going to do is you're going to go ahead and add those two terms together. You're going to go 4 plus a negative 2. And 4 plus a negative 2 gives you positive 2. So you're going to put that answer down over here. And from here we're going to repeat the steps. Now I'm going to take the negative 1 multiplied by 2 again, and I'm going to get negative 2. So negative 1 times a negative 2 is going to give me, negative 1 times a positive 2 is going to give me a negative 2. I place that over here. Add like terms. Negative 5, negative 2 is negative 7. Okay, repeat the process. So negative 5, negative 2 is negative 7. And then negative 1 times a negative 7 is going to give me a positive 7. So that goes over here. And the negative 6 and a 7 is 1. So that's the last part over there. Once you've done this, you've basically done the work. You've done the division. These numbers over here are set in a pattern, and they give you some pieces of information. And here's what we can get out of them. This first group of numbers over here, this represents the coefficients of our quotient. So coefficient of the quotient of the polynomial division. Okay, and it's always going to be 1 degree less than the original polynomial. I'll explain to you in just a moment here what that means. And this last part over here represents the remainder. So let's clarify and see what that means. So what this means is, as our division statement, 2x cubed plus 4x squared minus 5x minus 6 is going to equal. So we divided it by the expression x plus 1. So that's the first part that goes over here. And the quotient is the second part that we normally get. So the quotient is going to be this. These are the leading coefficients of the quotient. Since our original polynomial was degree 3, our quotient is going to be degree 2. So my quotient is going to end up being 2x squared plus a 2x minus a 7. You'll notice that this becomes the x squared term. Oops. The first number associates with the x squared term, the second one goes with the x term, and the last one becomes a constant. And this 1 by itself becomes your remainder, so plus 1. So really, we've done the polynomial division, and it's a bit quicker to do this rather than doing long division. Alright, so that was a brief overview of synthetic division. You may want to pause, go back, take a look at it again to try and really make sense of what we've done over here. Alright, now we can go ahead and finish off our notes with one final example here. This is what I've got, and I will set this one up for you, and I'll give you a chance to try it yourself first before I go over this with you. So first things first, I want to make sure that all the terms in the polynomial are here. So I got the x4, x cubed, x squared, x, and the constant. Good. I'm working with x plus 2, so I'm going to write down what information do I need. I need to compare x plus 2 with x minus a, because a is the value that I need to put outside the synthetic division. So x plus 2 can be written as x minus a negative 2, and then this would become the a value. So therefore, my a value is negative 2. Once I've got the a value, that's the part that's going to go outside your synthetic division, the negative 2. The top part here is all the leading coefficients, including their signs, so negative 3, positive 2, 3, negative 4, 5. Make sure that you're not making a mistake copying these down. That's where most common mistakes happen. And once you've got it set up, you are ready to proceed with the synthetic division. Right, let's go ahead and do that. First step, we bring down the negative 3. Next step, we multiply the negative 2 by the negative 3 to give us a positive 6. We add the 2 and the 6 to give us an 8. We multiply the negative 2 by the 8 to give us a negative 16. We add the 3 and the negative 16 to give us a negative 13. Multiply the negative 2 and the negative 13 to give us a 26. Add the negative 4 and the 26 to give me a positive 22. Multiply the negative 2 by the 22 to give me a negative 44. Add the 5 and the negative 44, and I'm going to get a negative 30. Now, once we've done that, all the work is done. We just got to recognize what information is where. So the first part minus the last terms, those are our coefficients, and the last part is our remainder. These are coefficients of the quotient. Okay, that's the easy part now. Now the last part, rewriting that as a division statement. So as a result, I get the following: negative 3x4, okay, 2x cubed plus a 3x squared minus 4x plus 5 is going to equal, our divisor was x plus 2. Our quotient is going to be starting with this and 1 degree less than what our polynomial was. Polynomial was degree 4, so our quotient is going to be degree 3. So I'm going to get negative 3x cubed plus 8x squared minus 13x plus a 22, and then I have the remainder of minus 39. Whew. And that is going to be our final This brings us to the conclusion of the notes for this section. If you have any questions, mark them down. Go ahead and give your practice questions a try, and then we will discuss any problems you have in class tomorrow. Thank you.